Questions 11 through 20 on the 2017 grade 12 AMC 12A. Claire adds the degree measures of the interior angles of a convex polygon and arrives at a sum of 2017. She then discovers that she forgot to include one angle. What is the degree measure of the forgotten angle? Well, anytime you have a polygon, convex polygon, the sum of the angles are always of the form 180 times n, whatever n is. So all of the angles would be 2017 plus that forgotten angle, which I will call x. So this is basically the formula. This has to be a multiple of 180. So I just would go through each of these answer choices and see which one gives one to substitute for x. That would give n as an integer. And when you do that, you'll find that the only one that works is when the angle is equal to 143. That is indeed a multiple of 180. You would get n equal to 12. So therefore, number 11, the answer is D. There are 10 horses named horse 1, 2 to 10. They get their names from how many minutes it takes them to run one lap around a circular racetrack. Horse K runs one lap in exactly k minutes. At time 0, all the horses are together at the starting point on the track. The horses start running in the same direction, and they keep running around the circular track at their constant speeds. The least time s greater than 0 in minutes at which all 10 horses will again simultaneously be at the starting point is s equal to 2520. Let t greater than 0 be the least time in minutes such that at least 5 of the horses are again at the starting point. What is the sum of the digits of t? Well, the horses are labeled according to the time it takes them to run one lap, and that is from 1 to 10. Now, the LCM is what we have to figure out in this question, least common multiple. Now, the LCM of all the numbers we can get by first breaking up all of them into their prime factors, and then we can take it from there. So this is 2 times 2 times 2, this is 3 times 3, this is 2 times 5. Okay, let's begin. So 2 I will have to include as many times as it appears. Maximum, it appears 3 times. So I will include it 3 times to get the LCM. The next prime number is 3, and it appears maximum twice, so include that twice. And then the next prime number is 5, so that's going to be included once, twice, only once, since it only appears once in terms of the maximum, in terms of for each entry. And then 7 appears maximum once, and there you go, that's the LCM. So this is, when you multiply it all out, 2520, and that exactly is what they got. So we know we're on the right track. Now we have to find the LCM of when 5 of the horses are again back at the track. So we only have to do it for 5. So let's try it for horse number 1, 2, 3, 4, 5. Those first 5 horses, let's see what we get. That LCM looks like it will be 2 times 2 times 3 times 5. And that is 60. But they want us to figure out the least time. Let's see if I can get a smaller number. How about if I figure out the LCM for horses number 1, 2, 3, 4, and 6? That's this LCM. 2 times 2, 2 times 3. Let's see here. 2 times 2 times 3, which is 12. Well, 12 is definitely less than 60. So 12 is the number that I'm looking for. In particular, that is what t will be. And the sum of the digits of that obviously are 1 plus 2, which is 3. So number 12, the answer is B. Driving at constant speed, Sharon usually takes 180 minutes to drive from her house to her mother's house. One day, Sharon begins the drive at her usual speed, but after driving 1/3 of the way, she hits a bad snowstorm and reduces her speed by 20 miles per hour. This time, the trip takes her a total of 276 minutes. How many miles is the drive from Sharon's house to her mother's house? Well, let's see here. Let's break this up. So we've got two scenarios. The first scenario is when she drives the whole distance at a certain constant speed. And of course, we're going to use the formula speed is equal to distance over time, or time is equal to distance over speed. And this takes her 180 minutes. And here we have a certain distance d. The second scenario is where 1/3 along the way, approximately here, so this distance is d over 3, and this is 2d over 3. She drives at s, but then this next part, s minus 20. And this is 276 minutes. So this information should be sufficient. The total time is going to be the time it takes her to go from here to here, plus the time from there to there. So using distance over speed, this distance is d over 3 over s, and the next distance would be 2d over 3 over s minus 20. And then from the first part, we know that speed is equal to distance over time, or time is equal to distance over speed, either one. But speed is equal to distance over time. Well, the time is 180 minutes, which is 3 hours. So since we're dealing with hours, I had to convert the 180 minutes to hours by dividing by 60. And then this time here, turning our attention to this equation, they told me is 276. But I have to divide that by 60 because I'm dealing with hours. Okay, so I got d over 3. S is also d over 3. 2d over 3. And then this is d over 3 minus 20. All right, so this is 276 over 60, and this just looks like 1. This is 2d over 3, and this looks like we can give a common denominator if we want to, or we can just invert and multiply d over 3 minus 20. So subtract the 1 from both sides, so 60 over 60, so this is going to be 216 over 60. And therefore this will be 2d on the numerator, and then this will be d minus 60 on the denominator. We cross multiply, and we get 216d minus 216 times 60 is equal to 120d, and therefore this will be 96d is equal to 216 times 60, and therefore d, when you do this math, is 135. So number 13, that answer is B. Alice refuses to sit next to either Bob or Carla. Derek refuses to sit next to Eric. How many ways are there for the 5 of them to sit in a row of 5 chairs under these conditions? Well, we will have to look at a few different scenarios. There's 5 of them. So the first scenario is when Alice is either in the first slot or the 5th slot, if she's here or here. Okay, so let's talk about her being in the first slot. So there's one way of doing that. Then next to her has to be Derek or Eric, because she cannot sit next to Bob or Carla. There's 2 ways that you can choose there, either D or E. Then after that, you can put here only Bob or Carla, because you cannot put Eric or Derek because they can't sit next to each other. You got 2 choices there. For here, you got 2 choices because you can have 2 people remaining. And then finally, there's only going to be 1 person remaining. So we have to multiply all of these guys, and when you do, you have 8. So when she's in the first spot, there's 8 ways of that happening. And very similarly, when she's in the 5th spot, there will also be 8. it will be the exact same sort of story. Then we look at when Alice is either in the second or in the fourth position. So either she's here or she's there. Okay, so let's see what happens when she's in the second spot. In the first position can be only D or E, Derek or Eric, because she can't be next to Bob or Carla. In the third, also either D or E. So I got two choices there, only one that's fixed and only one. If I put D here, only E can go there. If I put E there, only D can go there. And then here, I have to put either Bob or Carla, two choices, and then whoever's left goes there. So when I multiply these guys, I get 4. So when she's in the second spot, there's 4 possible arrangements, and when she's in the fourth spot, it will be the same, fourth. You'll see that it works out the same way. And then now, finally, we have only one other scenario, and that's when she's in the third spot. Okay, when she's in the third spot, next to her can only be D or E, because she cannot be next to B or C. So we got one fixed spot. We can put 2 here, and then whoever is put there, the other guy goes there. And then the last one, of course, B or C, 2 spots, and then the last person goes there. So as you can see here, we've got 4. So when she's in the third spot, there's 4. Now we add this all up, 8, 8, 4, 4, 4. And when you do, you get 28. And therefore, number 14, the answer is C. Let f of x equal sine x plus 2 cos x plus 3 tan x using a radian measure for the variable x. In what interval does the smallest positive value of x for which f at x equals 0 lie? Well, I graphed it using some basics. So what I did was I just used 1, 2, 3, 4, 5, since the range only goes up to 5. And for each of these, I just plotted a radian measure and get very approximate values to figure out the graph. And the graph of this function looks like the following. So here is the graph of this function. And as you can see, when it is between the first interval from 0 to 1, it never crosses. It always just gets bigger and bigger. The next interval from 1 to 2, it's actually, you can't really see it in this graph, but it's just going to get bigger and bigger and bigger like that. And then what happens is when you get to a certain asymptote, the graph approaches that asymptote. And that asymptote is basically pi over 2, which in radians is 1.57. And the way you can figure that out is that this function is sine x plus 2 cos x plus tan x, right? 3 tan, but tan is sine x over cos x. So that means that cos of x cannot equal 0. And that means that x cannot be pi over 2, and similarly 3 pi over 2, and so on. And in radians, those numbers are 1.57 and 4.71 approximately. So whenever the graph, if you notice, is going to be 1.57, which is approximately here, it will never reach it. That'll be sort of like an asymptote. So it kind of approaches it but never touches it. And similarly at the bottom, you'll see it's kind of behaving that way also. So those blue lines represent the asymptotes, 1.57 and 4.71. And then you'll notice from the next interval, I think I talked about this one, 1 to 2, which is here, it never will cross. It'll just keep going here, and then it'll keep going down. The next interval would be 2 to 3. 2 to 3 is from here to here, and as you can see, it's on the graph. It's basically just going down. It's below the x-axis. And then 3 to 4, well, 3 to 4 is here, and as you can clearly see, that is when it crosses the x-axis and gives you a root. So the answer is D. And then 4 to 5 is basically here, from here to here, And then as you can see, during that range, it just keeps going up, approaching the asymptote. So the answer to number 15 is D. In the figure below, semicircles with centers at A and B and with radii 2 and 1 respectively are drawn in the interior of and sharing bases with a semicircle with diameter jk. The two smaller semicircles are externally tangent to each other and internally tangent to the largest semicircle. A circle centered at P is drawn externally tangent to the two smaller semicircles and internally tangent to the largest semicircle. What is the radius of the circle centered at P? This diagram is at the heart of our question, so we will use it exclusively, of course. Let's draw some lines from A to P, P to B, and then we have to also look at the center of the big semicircle, and that's approximately here. So I'm going to draw a line from there to the edge like that. And I think that should be sufficient. One more line is necessary, and that's a perpendicular from P down to the base like that, where this is a right angle. And there we go. That should be enough. Okay, now of course we have to label. This is 2, this is my R, radius, radius, radius. And this is also R. And this is 1. And this is 1, this is 1, and this is 1. And then from here to here, that I will label X. I'll write that in red just to sort of show that it's a little bit different. That is X. And then the top to bottom I will call H for height. And then this distance, well, the entire distance from here to here is 6, so that means the radius of the big semicircle is 3. So from there to there is 3, and therefore from this distance is going to be 3 minus R. Now at this point we have to come up with some equations, and we do that using Pythagoras. So the first one is involving that triangle. That is going to give me that h squared plus x plus 1 squared is equal to the hypotenuse, which is 2 plus r squared. The next one is that triangle. That's going to give me h squared plus x squared is equal to 3 minus r squared. And the third and final one is that triangle, and that's h squared plus this distance, which is not 1, it's 2 minus x. 2 minus x squared is equal to the hypotenuse, which is r plus 1 squared. Okay, we've got a system of equations here, 3 variables, 3 equations we can solve. So the first thing is from here, I can isolate for h squared. That's going to be x plus 1 squared minus 2 plus r squared, like that. And I can substitute that into here. So plus x squared is equal to 3 minus r squared, like this. So let's expand this, and we get 4 plus 4r plus r squared minus x squared minus 2x minus 1 plus x squared is equal to 9 minus 6r plus r squared. Okay, r squareds cancel, this x squared cancels, and looks like we have, let's see here, 4r minus 6r, so this r and that's going to be 10r. And on the other side, it'll be 2x, 9 minus 3, 2x plus 6. And this is 5r is equal to x plus 3, and therefore x is equal to 5r minus 3. Okay, that's a pretty good result. Now let's work with this one here in a very similar way. Remember the h squared we had put in very similar to before by isolating from there. We do the same thing. 2 plus r squared minus x plus 1 squared plus 2 minus x squared is equal to r plus 1 squared. Okay, again, let's expand this. So we got 4 plus 4r plus r squared minus x squared minus 2x minus 1 plus 4 minus 4x plus x squared, and this is r squared plus 2r plus 1. Okay, collect like terms. That cancels with that. X squared minus cancels with x squared positive. 4r and 2r, so that means this is going to be just 2r minus 2x minus 6x, so that'll be 6x on that side. And then the numbers, let's see here, 8 minus 1, 7, and then minus 1, so I got a 6 plus 6. Okay, divide through by 2, r plus 3 is equal to 3x. Okay, well, I know that x is equal to 5r minus 3, so let's substitute that in. So r plus 3, and then 3 times x, which is 5r minus 3. So this gives me r plus 3 is equal to 15r minus 9. So that means 14r is equal to 12, and therefore r is 12 over 14. In lowest terms, that is 6 over 7. 6 over 7 is the value for r, which represented the radius, and therefore number 16, the answer is B. There are 24 different complex numbers z such that z to the power of 24 is equal to 1. How many of these is z to the power of 6 a real number? All right, so z to the power of 24 is equal to 1. And the roots of 1, the 24 roots of 1, are of the form z. Each of them has this form. Z is equal to e to the k pi I over 12. Some of you may have seen this before, some of you haven't, so I'll teach you. And then k in this case, since there's 24 roots, it goes anywhere from 0 to 23. And therefore z to the power of 6, if you take this and just raise it to the power of 6, it'll be e k pi I 12 all to the power of 6. And that is e k pi I over 2. And now this is going to be expanded using the standard form, which is cos k pi over 2. That's the real part. And then the imaginary part is sine of k pi over 2. And this is going to be a real number if this part is equal to 0. So real if sine k pi over 2 is equal to 0. And that happens when k is even. So if we look at k is between 0 and 23. And half of those k's are even. So half of those 24 are even, and half of 24 is 12. Since half of the values of k are even, half of the 24 roots are real. And half of 24 is 12. So 12 are real, and therefore number 17, the answer is D. Let s and n equal the sum of the digits of the positive integer n. For example, s at 1507 is 13. For a particular positive integer, s at n is 1274. Which of the following could be the value of s at n plus 1? All right, so obviously this is a very big number for the sum of the digits. So it's going to be a big long number. So to make it easy, let's just use the biggest number, which is 9. 9, 9, 9, 9, a whole bunch of 9s. Well, first of all, is this divisible by 9? And the answer is no. But I can get sufficiently close by using 141 of them. And then I have to add on another 5. And that's how I get this number. It's the sum of the digits, so it's 141 of those 9s plus a 5. And that gives me 1274. So now what we have to do is we have to play around with this in order to get s at n plus 1. If I just tack on a 1 and make this a 6, it's going to make this 1275, which is the easiest way or the simplest way, but 1275 is not one of the answer choices, so it's not going to be that easy, of course. So we have to fiddle around. What do we do? Well, I can move the 5. It doesn't have to be the last digit. It could be the second last digit. It could be like this. This is now 140. This is the 141st, and I got a 5. So again, I have 141 9s plus a 5, and that is 1274. But for this, if I add a 1, I get s at 999 all the way, 140 of those, but 60. And now let's see, what is the sum of the digits? It would be 140 times 9 plus a 6. That number is 1266. Not one of the answer choices. All right, you keep going. And for the sake of time, I'll show you. You just have to keep moving the 5 backward. When you get to this point, 9, 9, dot, 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 where you have moved it so that there's 137 here, a 5, and then we've got 4 9s, 9, 9, 9, 9 here. This, again, 137 plus 4 is 141. 9s plus a 5, that is 1274. But now let's see what happens when I add 1 to this number. When I add 1 to that number, it becomes 99 dot dot dot, 137 of those, but this becomes 60,000. So this sum of the digits would be 137 times 9 plus a 6. And that is 1239. And that is one of the answer choices. It is choice D for number 18. A square with side length x is inscribed in a right angle with sides of length 3, 4, 5, so that one vertex of the square coincides with the right angle vertex of the triangle. A square with side length y is inscribed in another right triangle with side lengths of 3, 4, 5, so that one side of the square lies on the hypotenuse of the triangle. What is x over y? Okay, well, this one we'll start with x, x, and so on. And this is 3, this is 4, this is 5. So this segment here would be 4 minus x. This segment in here would be 3 minus x, like that. And I think that should be good enough to figure out x. You use similar triangles. 4 over 3 is equivalent to the sides on that triangle. So 4 minus x over x. Cross multiply, you get 4x is equal to 12 minus 3x. 7x is equal to 12, and therefore x is equal to 12 over 7. So quickly we're able to figure out x. Y is going to be a little bit more complicated. This is y. This is the square where the side is on the hypotenuse. And as before, this is 3, 4, and 5. This distance, however, I will label z, and then therefore this distance will be 5 minus y minus z. Okay, now we have to use similar triangles, but it's not as obvious, so let's insert some angles. This is theta. Well, this is a right angle, we know that, so that means this is 90 minus theta. This is a right angle, and therefore this guy in here is 90 minus theta, this angle. Okay, so now we have a little bit clearer of an idea of what the similar triangles will be. Okay, so here we go. the equation I get first is that z over y is the same as 3 over 4. So I'm comparing this small guy to the big one, the entire one. That's the first one. So from that one, I can isolate for z that it's 3/4 of y. And then I will use another similar triangle situation. This is obviously a right angle here, and this is theta. So this is also similar to the big guy, the 3, 4, 5. From that, I get that 5 minus y minus z over y is the same as 4 over 3. And I can substitute this. So let's cross multiply first. 4y is equal to 15 minus 3y minus 3z. So that means 7y is equal to 15 minus 9y over 4, like that. So if I multiply through by 4, I'll get 28y is equal to 60 minus 9y. So that means this will be 37y is equal to 60, and therefore y is equal to 60 over 37. And now I have to figure out x over y. So x over y is going to be equivalent to 12 over 7 over 60 over 37. And if you invert and multiply, it will be 12 over 7, 37 over 60. So that looks like 37 over 35. And therefore, number 19, the answer is D. How many ordered pairs AB such that A is a positive real number and B is an integer between 2 and 200 inclusive satisfy the equation the log of A to the base B all to the power of 2017 is equal to the log of to the base B of A to the power of 2017. All right, so log of A to the base B to the power of 2017 is equal to the log of A to the 2017 to the base B. All right. Okay. Using log rules, the 2017 can come out front. For this guy only, you got to be careful about the notation. So the log of A to the base B. And then this one, not much I can do really, all to the 2017. So to make things easy, I will let the log of A to the base B equal x. So this becomes x to the 2017 is equal to 2017x. And therefore, if I put everything on one side, 2017 minus 2017 times x, factor out the x, and I get x to the power of 2016 minus 2017. So that means x is equal to 0, or x is equal to, well, x to the power of 2016 is equal to 2017. So x is equal to the 2016th root of 2017. That's the format. Okay, well, let's first start with this guy. And let's remember that x is going to be, since 2016 is a even number, it's going to be plus or minus. So it'll be plus or minus some number k, whatever this is. I don't know what the value is of that, but let's just say it's k. Okay, so let's start with x equals 0. If x equals 0, we have the log of A to the base B is equal to 0. So that means B to the power of 0 is A. So that means A is equal to 1. And B can be anything. B is between 2 and 200. So B can be anything between 200 and 2. So that is what, 199 values? So we have 199 pairs. They would be 2, 1, 3, 1, ... all the way until 200. Or actually, I have to put them in reverse order. A is 1, so B is 2. Right, ... until you get 100, 1 and 200. So A is always 1, and B is anywhere from 2 to 200. So these are my pairs, my ordered pairs. And as you can clearly see, there will be 199 of them. Okay, so that takes care of that part. Now we turn our attention to this guy, which is when x is equal to plus or minus k, where k is this value right here, whatever that is. I don't have any idea what that is, what it's equal to, 1 point something, but I don't know. So let's see. Log of a to the b is equal to plus or minus k. So that means the log of a to the b is either equal to k, or the log of a to the base b is equal to minus k. So for the first one, that means b to some number is equal to a. So that means, again, we're going to have a whole bunch of pairs that are of the form bk, which is a, and then b can be pretty much anything. A is fixed as this, but b can be 2 and 3 all the way down until you get to 200 for the value for b. Like that. So all of these are going to be of the form AB, which is b to the power of kb, since a is equal to bk. And then you can just put in the b values from 2 to 200. So 2 to the k, 3 to the k, 200 to the k, and so on. And k is, as previously mentioned, this value, some number. And this gives you 199. And in a very similar way, you will see that you get the same story for this guy. When it's negative k, AB will basically be b to the negative k is this time a. So it will be b to the negative kb for all the values from 2 to 200. So that's going to be 2 to the negative k2, 3 to the negative k3, and so on all the way down to 200 to the negative k200. And this gives you another 199. So at the end, when we add them all up, we had, let's see, 199 here, actually over here, 199 here, and 199 there. So 1, 2, 3 times 199. 3 times 199 is 597. So number 20, the answer is E.